All right, taking a look at the transformation quiz review. Most of this is going to be dealing with GeoGebra, but some of it will be just doing it by hand. I'll kind of try to show you both ways. Some things you might want to take a peek at. If you go inside the folder, I did put a transformation rules PDF on here. So when you open that up, it basically gives you somewhat of a cheat sheet that'll kind of have the reflections and the rotations on there and what happens to the coordinates. This is kind of a nice little way to check your answers and see that if you're doing them right. Sometimes it gets a little confusing doing it this way. You kind of second guess yourself and miss negatives, so doing it in GeoGebra may be better. I don't know, it's kind of up to you, but I just want to let you know that it's there. Also, I'm going to be referring to this transformation quiz review, which is basically going to gives you all the answers, and then there's some little things I'll write on here kind of as we go, or just talk about. I guess I'm not going to write because I'm over here at my computer to do the GeoGebra part, and I'm not actually writing on the board itself. So let's kind of get started. So number one, ABC has coordinates. These are your three coordinates. The translation, if you want to just use the coordinate rule, you could kind of say, well, it looks like every x becomes x subtract 5. So you could do 2 take away 5, get -3, 7 take away 5, 4 take away 5. That gives you those points. And then the y's, you are going to subtract 3. So you go 5 minus 3, 2 minus 3, and 7 minus 3. Basically, if you're talking about left, right, up, down, subtracting 5 from your x coordinates, you're moving 5 to the left and 3 down. So 5 left and 3 down. So on GeoGebra, it's going to look something like this. So when I graph my polygon and I put my points, our first point was at 2, 5, and then we go to 7, 2, and then we go to 4, 7, which would be right here, and connect it back. And now if I want to move it 5 left and 3 down, I could create a vector and go, just start it wherever and go 5. Actually, I'm going to move it over a little bit. I'm going to undo that last step and create a vector again, give myself some more room. So we'll go 5 left and 3 down. Should put it right here. And now I can simply go and do my translation. Before I move it, though, I do want to get these coordinates so I don't have to do it again. So I'm actually going to get those coordinates really quick. I hit Control, highlight all the corners, right-click, show the value. We've done this quite a few times, and maybe I'll kind of scroll down just a little bit so we see what's happening. And now we're going to go ahead and we're going to translate this shape, that magnitude and direction, and then you're going to get all your new points. So hopefully these points, the -3, 2, the 2, -1, -3, 2, 2, -1, they do match up with our rule. So the rules are probably faster, but sometimes you might need the GeoGebra to kind of help you see what's going on. So moving on to number 2, they give us a triangle. They say write the coordinates under a translation that uses a vector -2, 6. So this is just vector notation. Really, you can treat it the exact same way as number 1. Your xy is just going to go to x minus 2, y plus 6. So if you're talking layman's terms, and I don't know if this little marker over here actually works, if I can write using this. Looks like not. But it basically means I'm going to go left 2, up 6. Left 2, up 6. So I could go back to my old grid and kind of change my points. So I'm going to go back to the old grid. I'm going to undo a couple steps. Undo the vector. And let's just move this thing around and put it where it's supposed to be. So A was, for this problem, A was at 2, 2. B was at 5, 3. And C is at 9, 1. Right over there. And now I'm going to want to go in and I'm going to want to get my points and show the values. I wish it would just keep those, but show the values. And now what we want to do is we want to go left 2, up 6. So I create a vector making sure I have enough room here. So maybe I'll start here and I'll go left 2, up 6. And now I can just go ahead and I can move that shape. I can translate it. I want to translate this shape by this vector. And it flew off my screen a little bit, so I got to yank the screen down. And it looks like I have some new coordinates. Hopefully these match up. 0, 8, 3, 9. Let's just see. 0, 8, 3, 9. Yep, looks good. Now, using the rule, you could have just subtracted 2 from the x, 2 from the x, 2 from the x, and then added 6 to the y. Add 6 to the y, 6 to the y, 6 to the y. So, could have did it either way. Question number 3, what is the magnitude of that translation? So that's where you want to use the Pythagorean theorem. The answer came out to be 6.3. If you want to kind of cheat and not do the Pythagorean theorem, you could use Geogebra, and you could say, hey, I want to find the length of this line. The problem is it's probably going to be rounding to the nearest tenth. So let me go check my settings and click the little gear. Then I think it's the second gear over here. And I could say 1 decimal place. All right, or you could go to 3 decimal places. I'm going to go to 1. And that way I'm going to measure. I'm going to say, hey, what is the length from D to E? 6.3. So you get that, or you could have did the Pythagorean theorem and built your legs and did leg squared plus leg squared equals hypotenuse squared. Either way would work. All right, next one, number 4, says they give you a triangle. Write the coordinates of the image under a reflection over the x-axis. So the x-axis, this was the rule. We kind of put this on our note sheet if you have your files saved, or if you want to use the cheat sheet that I put on Schoology. But it looks like x stays the same, but y changes sign. So notice all your x's should stay the same, and all of your y values change to a different sign. So if you're using the rule, you could do that. I'm going to go ahead and I'm going to do it on GeoGebra just to show you how that works. So let me get rid of a few things. I don't need the vector. I'll keep that original triangle so then I can just move it around. So for number 4, we had A was 1, 4. So there's A. B is 4, 1. This is actually faster than doing a new sketch every single time. And then we have 1, -1 for C. So there's our triangle. And we want to reflect over the y-axis. So basically I just say, hey, I want to reflect U over the y-axis. Click on it. Bam. There's all our new points. Everything is good to go. We could kind of move these away so we can see them a little bit better. But hopefully these are our answers. -1, 4, -4, 1. Let's just double check. -1, 4. Ooh, what happened to B there? B was supposed to be at 4, 3, and then 2, -2. Oh, I was on the wrong question. I was actually looking at number 5. So let me go back and just tweak my, my GeoGebra. No, don't save that. So helps if you get the right points. So A was at 1, 4. B was supposed to be at 4, 3. And C was supposed to be at 2, -2. There we go. Now our new points should line up with our answer key. -1, 4, -4, 3. So it looks like, oh, so crap. I messed all up. So number 4 was supposed to be over the x-axis. Doggone. So over the x-axis. So let's just kind of take this person, apologize here, take this person, reflect him over the x-axis. That'll help. And now we should have the coordinates that we need. Now we should have our 1, -4, our 4, -3, and our 2, +2. And yeah, now it matches up good. All right, number 5. Now we're reflecting over the y-axis. So the rule when you reflect over y is you change the sign of the x and you leave the y alone. So again, you could just change the sign of x, change the sign of x, change the sign of x, and then leave the three y numbers the same. So be careful on the test though, because number 5 might not be the y-axis. It might be the x-axis or some other line. So don't just assume every single number is going to be the exact same. So be kind of careful there. But let's go to GeoGebra. Let's kind of undo everything up until that very first. Now we'll make our changes. So I'll try to do the right one this time. A is at -1, 3. B is at 4, 1. And C is at 1, -1. So let me just make sure that this is the right question. We're doing number 5. -1, 3, 4, 1, 1, -1. -1, 3, 4, 1, 1, -1. Looks good. And now we need to reflect that over the y-axis. So I want to do a reflection of this over the y-axis. Boom. And now I got some new points. My new value should be 1, 3, -4, 1. Let's just check that. 1, 3, -4, 1. And then double -1s, double -1s. Looks good. So GeoGebra verifies it. Moving on to number 6. 6 says we have a new triangle, so I got to change those coordinates. Now we're going to want to reflect over the line y equals x. Well, that rule, when you want to reflect over y equals x, the rule says just change places. So basically you're just switching. 5, 0 becomes 0, 5. 7, 2 is 2, 7. 5, 4 is 4, 5. We can verify it. So I got to make sure I get the right points, and we're doing y equals x. So undo. Let's get the right points. So for we're on number 6. We want 5, 0 for A, 7, 2 for B. You can kind of feel when it snaps right to it. And then 5, 4. Oh, that's 4, 5. Almost messed up. 5, 4. There we go. So we got this triangle here. We now need to reflect it. The line y equals x is this line with a slope of 1 and a y-intercept of 0. So I need to create a line that goes through this point and heads right up at 1, 1, 2, 2, 3, 3, and so on and so forth. And let's reflect it over that line. So reflection. There we are. And now we can pull it down a little bit. And now we have some new coordinates. 0, 5, 2, 7. 0, 5, 2, 7, 4, 5. Looks good. Verified. Number 7. New triangle. Rotating 90 degrees. So if you remember from Khan Academy, the 90-degree rotation, we're going counterclockwise, 90 degrees, quarter turn. And the x and y trade places, and the y changes its sign. So if you're good enough to do that with the coordinates, you can make x and y trade places, and x keeps his sign, y changes. So you could do it that way. I'm going to do it using GeoGebra. So backer, backer, backer. Let's readjust the triangle. It's kind of nice when you just keep readjusting. You don't have to keep changing, finding the value and all that stuff. So our triangle is A was -4, 2. Boom, -4, 2. B is -2, -1. And C is -6, -3. Boom. All right. So we got our original, the OG, and we need to do a rotation of 90 degrees around the origin. So we need a point at the origin. So let's give ourselves a point right there. And we need to rotate this guy 90 degrees, a quarter turn, fighting the clock, counterclockwise. So here we go. We want to rotate around a point. We need to select the object, and we need to select the point. And unfortunately, why did it do it 90 degrees? I want to tell you how many degrees I want you to do it. So rotate, oh, I did reflect. Rotate around a point. Rotate U around U 90 degrees counterclockwise because that's positive. Okay? And now we got a new point, a new spot with answers. -2, -4, 1, -2. So -2, -4, 1, -2. 3, -6. 3, -6. Looks good, more money. So we got that one figured out. Number 8. Now we want a rotation of 180. New triangle, rotation of 180. The rule says leave them alone, but change both signs. So you could leave the 1 and the 4 there, but make the 1 negative, the 4 positive. So that's what the rule says. Let's follow Geogebra. Boom, boom. And we need to change our triangle. So for number 8, we need 1, -4 for A. Right 1, down 4. B is 5, -1. C is 6, 3. Positive 6 up to 3. Oh, 6, -3. Gotta be careful. Get all my positive and negatives right. All right, so there's our spot. We have our point, so we should be good to go on this one. We want to rotate this shape around that point, and this time we want to go $1.80, halfway around the circle. There it is. And hopefully these match up with our answers. -1, 4, -5, 1. -1, 4, -5, 1. -6, 3, -6, 3. Beautiful. Life is good. Number 9, we need to do a glide reflection, which is a flip and a slide. Flip and a slide. So the slide, when it says x goes to x, that means don't do anything with the x coordinate. But then the y coordinates, we need to move it down 5. So if you're using words here, it's don't move left or right, just go down 5. That's what this is saying. And then we need to reflect it across this vertical line, x equals -2. So this is going to be really hard to do without GeoGebra. So just think in your head, what we need to do is we need to go down 5, reflect it about that line, x equals -2. So let me get the triangle first. So get our triangle. A is 1, 2. B was 6, 4. So B's got to go up to 6, 4. And then C is 5, 1. 5, 1. And we needed to go down 5 and then flip it over, x equals -2. All right, well, let's do down 5 first. I'm going to make a vector, and I'm just going to say, hey, let's just go down 5. Lock it in. So translate this guy straight down 5. Now we need to, that was the glide. Now we need the reflection part. And the line x equals -2 is a vertical line right here. If I said y equals -2, it would be a horizontal line. So be careful. Y is horizontal, x is negative. So let's make our x line. Oh, I don't know why I picked parallel line. I want a line right here that goes down this way. And we need to flip or reflect this, not the original, but the one that we glided down. We need to flip that over him. So it looks like we got some new coordinates. Hopefully these match up with our answer key. -5, -3. So -5, 3, 10, 1. -5, -3, -10, 1. -9, -4. Is that good? -9, -4, money. So translation, flip. And then we have a couple left. We say if a figure is reflected over two parallel lines that are 8 inches apart, what is the result? And we're saying it's a translation 16 inches. And that's true because there is a theorem that says when you reflect over two parallel lines, it's really just a translation. And how far, the magnitude is always double how far the lines are apart. So I could actually show this. This one you could make up your own figure. So let me just kind of undo a bunch of stuff. And we could keep this original shape if we wanted to. And let's just put in, let's put in 2 lines. So we could put in, let's just use the y-axis. And then let's do another line, 8 inches. We'll pretend each of these squares is an inch. So I'm going to put another line in 8 inches away. Oh, come on, man, lock it in for me. We're locked in. So if I reflect this shape over the y-axis and then over this line, let's see how far it went. So we need a double reflection. Reflect him over line number 1, and then reflect him over line number 2, which was 8 inches away. Well, ultimately what happened was we went all the way from 5 to -11, which is a grand total of 16. So basically 2 reflections over parallel lines, you end up translating twice that distance. Last problem says, what happens when you reflect over not parallel lines, but 2 intersecting lines with an angle of 60 degrees? Oh, what's a quotation mark? Should be between 60 degrees between them. Well, the result, whenever you reflect over intersecting lines, it ends up being a rotation. And similarly, it's going to be double the angle. So let's kind of show this one. We'll wrap this up and show this one in Geogebra. So undo, undo, undo. And let's just kind of go. I'm going to make 2 lines. These lines don't really matter. Just kind of make a line here and, a line here somewhere. What I do need to try to make happen is I do need to try to make this 60 degrees. Well, right now, I don't know how many degrees it is. So I want to measure this angle, but I don't have a point officially yet. So let's put a point right here, right at the boom. And it's locked in there, hopefully. And actually, to do it, to be safe, I'm going to choose a special point. I'm going to choose an intersect point. And I want to know where this line intersects this line. And now it locks it in. So if I move the lines, nothing goofy happens. Well, I want to know how many degrees this is. I want 60. So let's measure 60 degrees from E to I to G. Well, we're close. We're at 56.4. So let's move this line to get right to 60. Perfect. All right. Well, what I'm going to do is I'm going to reflect this shape over this line, then over that line. So a reflection over 2 intersecting lines, reflect him over this guy, and then reflect him over this guy. And let's kind of see what happens. Now my coordinates are a little bit off because this is probably not perfectly 60 degrees. It's probably like, 60.02 or something kind of weird. Let me just see if, and the coordinates might not even matter. What really matters is, did this thing rotate around that point 60 degrees? Well, there's only one way to test. And let me just kind of show you how I can test. I'm going to create a couple segments from here to there. So this is where A started at. Then A is going to rotate to get me to here to there. And now I want to measure this angle, this big angle. Hopefully it's double the 60. So measure the angle from here to here to there. And it kind of landed right on top of him. But sure enough, the big one is 120. The smaller one is 60. So I think life is good. It was a rotation twice of the magnitude of what it is. So I know this video was a tad on the longer side, but we had a lot of problems. Again, feel free to use Geogebra. Feel free to use the rules if you're comfortable with them. But the big thing to be careful on is positives and negatives and not mixing up X and Y. I looked at the review and some of the answers that were submitted on there. Some people missed some just because of simple mistakes. So try to cut those out tomorrow on the real quiz. See you.